By the way, yes, you need to absolutely be connected to the internet. Oh, how much I hope I don't have to add the third class here, guys. It's already. But if I have to, I will. So if you go to Files, Instructions for downloading, that's the very first thing you will do. And unless you added the class very recently, you should be able to follow it. This is in Windows Explorer. Okay? Not Internet Explorer. So you go to Windows Explorer. Yeah, I'll do it. Usually Windows 8 brings you Windows Explorer. And you click Libraries and type it. I think that's how it works. That's how it works. Right?
Yeah, I think it takes a second.
It takes a second, okay. Yeah. What did I do now? Okay, well, takes that long?
It takes about 5 minutes.
Yeah, it takes a long time.
Oh.
And then for mine, like it says that it cannot access the file. And I don't know if it's because I just registered this morning, or I'm not sure, but it was mad at me.
Are you logged on to US Wi-Fi?
Yeah, I was logged on. To
Yes,
I have a method that
Tao.
access into folder memory.
Yeah.
Okay.
And
This chair is really comfortable.
go to the computer, Mac Network Drive. Yes, and choose any drive that you don't have right now, and put the folder link that in the Word, copy it into here, and click on the connect and connect using the different credentials. Credential, and then click OK and put your UFID and password in it. So you should able to map your folder from Dr. Swarno's folder, and then you can
Did you
download.
follow it, or did she go too fast and you want her to do it, to say it again?
So
Say it again, Tao, a bit slower.
okay. So the way is that first go to the computer.
Okay, try it, all of you who haven't succeeded yet.
Everyone follow? And click on the Map Network Drive.
Now,
I'm learning it.
does anybody here have Windows 10? Because it'll look different. Right. When you're on this PC, in the top right corner, just below the X, there's a little arrow pointing down. Click that little arrow next to the question mark, and then Mac Network Drive will be there.
Make sure you don't map into a drive that you already have.
Yes, make sure you don't map the drive that you already have. And the way is here, like choose the drive that you don't have, and then just choose anyone that you don't have, and copy the folder from the.
Because it'll then map it to your C drive, which means then your C drive will be locked into the UFI.
Copy the folder
So
from
you
this
copy this
link.
last add here. Okay, go ahead. Lynn.
Okay.
Nothing?
Huh? How's it going?
Wait, if you do it wrong, you do this?
You disconnect essentially your C drive, which is where all your content is stored.
Oh, that's a problem. Dude.
It's impossible.
So your computer doesn't even know what it is.
You would probably have to
It works for me.
Yeah, if you just delete system 32, it fixes it.
Doesn't look like it's any faster than what I'm doing. But think that maybe that will work for some of you. Here is the information though. I will need to send an email for anyone. Well, actually, no, I think all of you are registered in the class now.
I know.
If you cannot run it or install it, you need to go to the 4th floor of the main chemical building. I don't remember the exact room number, but it's right next to Dr. Butler's office. And it says on the door, IT. Okay? It may say IT support. We have 2 excellent people. I have it installed, so for me it's okay.
Yeah, but you're yeah, so when you just plug in
Anyway, so go to the IT room, 4th floor main building. Depending on the day, either Victor or Ramai will be there. They're very nice, they're very helpful. They'll stay with you until we have succeeded. So, okay. So, how many of you have successfully installed it so far? Okay, about half the class. All right. Okay. Well, I hope by Monday you'll all have it installed. So, after it's installed, that's not what I meant to do. You need to run under all programs. Honeywell is the company that has Unisim. And actually, let me give you a little bit of history. Traditionally, the grandfather of chemical engineering simulation is a software by the name Aspen. This was developed at MIT, and it did a lot of good things, but the interface was a nightmare. And so newcomers came on, and the most successful was a program called HYSYS, which has a much better user interface. To be frank, in some things it's not as good as Aspen. For solids, if you have solids, forget about HYSYS. HYSYS was getting market share, and what eventually happened, Aspen decided to buy HYSYS. But because the two together would have over 70% of the market, the only way the regulators would allow that was if Aspen sold the software HYSYS also to another company. So Honeywell was that company. And they took HYSYS and they called their version of HYSYS Unisim. They claimed they hired 14 of the 15 original HYSYS programmers. For many years, HYSYS and Unisim were practically identical. I was doing some things in HYSYS and the students were following in Unisim or vice versa. Just minor differences that developed. Until about a year and a half ago, Aspen totally changed the interface of HYSYS. So the interface is now different. But underneath the interface, the program behind it is practically the same. So I can't anymore tell you that you completely have also learned HYSYS, but it's a very easy transition from Unisim to HYSYS, just the interface. All the internals, all the tricks you learn, everything is identical. Well, okay, one caveat. If you go to HYSYS, you have two choices. Do you use the HYSYS thermodynamic package or the Aspen thermodynamic package? If you use the HYSYS thermodynamic package, it's identical. And you get identical results number-wise and everything. The thermodynamic models are identical. If you choose the Aspen, it will be somewhat different and it's a little bit more buggy, to be honest. Okay? So what we have here is Unisim. Okay? For chemistry students here, we also use Aspen and we have HYSYS in the capstone design class, but we're keeping it only in the capstone design class because we're buying 150 licenses, and that's just barely enough for our design students. Okay, so for all other classes, we're using Unisim, and there is no reason not to use Unisim. Okay, and I'm using Unisim in the capstone design. Simply, I'm using Aspen for some things, but Unisim doesn't have. All right. So after you have successfully downloaded it, you would go to Honeywell, and you go to where you say ULM config wizard. Click that. You need to run it always as network. Next, you type Unisim right here under server name, unisim.che.ufl.edu, and then click add. It will bring it here. And then click finish. In my case, I'll just cancel. So, after you have installed it, if you go now to Unisim, this will show up. As I mentioned in my announcement, we are running an older version of Unisim. A newer version 4.10, I found bug in some things that actually affected this class. So that's why I have been using 3.80 still. There's a brand new version of Unisim that I have not had an opportunity to test yet. If it looks good, everything, I might switch us to the brand new Unisim. We'll see. This is the starting screen. You know you're okay if, when you click File, New is enabled. If you see New Case, you are okay. Are you all seeing New Case? We have Unisim. Good. Click it. The first thing, going back to the history. At the same time, I mentioned how the Aspen user interface was awful. At the same time, Aspen changed the HYSYS interface, and I'll have to tell you the truth. They made the HYSYS interface worse. It has some logical irrationalities. In Unisim and in the old interface, you could find all general reactors like conversion, together with the CSTR and PFR, they're all one group. In the new interface, conversion reactors and all those are together with columns, not with reactors. Go figure. Just one example. But the new HYSYS interface, which is worse than the old HYSYS interface and Unisim interface, became practically the new interface also of Aspen. So Aspen now has a pretty good interface. That's what they did. So basically they merged the interface of HYSYS and Aspen, and they came with a merged interface that is pretty close to HYSYS. It's much better than the old Aspen interface, a little bit better than, a little bit worse than the old HYSYS interface. So that's what we do. Okay, the first thing you add here is add your components. We're going to do this problem with the valve. We have only one component, nitrogen. What you do here, and you can see here a tag that says components. You click add. And it can be a challenge to find under what name the component is. For example, ethylene you will not find. The funny thing is you type ethene, you find it, and it types the name ethylene. But under ethylene you will not find it. So it can be a challenge to find what it is. But for nitrogen you can immediately see it nitrogen, or you can type N2 and it will show nitrogen. And once it shows up and it's highlighted, click Add Pure. Everybody has done it? If we had more components, we would be adding more components. Actually, let's add one more. Let's add water also. Type water, add Pure. Okay, so I added two components. One problem with the interface, get used to it, is that unless there is somewhere to click OK, You accept choices and leave the screen by pressing X. We're not yet done with it, but I just wanted to say it before I forget. Actually, no, we're done with it. Yeah, mistake. So we're done with the components. You press this X. Be very careful. Sometimes in laptops, it has happened to me, this could be, particularly when you blow it up, can be that so that you don't see it. And if you don't see it, the X that you see is this. This X takes you out of Unison. You exit the program. It's the wrong X. You see right now, you don't see the X to press. Let me go back to shrinking it. That's the X I need to be pressing. Be careful not to do it, okay? So, and we're back in the other screen, and you see here component list. The second tag we want is fluid packages. Click Add. We have a choice. Let me blow it up. Okay, my actual height of a lot of thermodynamic packages. You haven't covered it much, if any at all, but in this class we're going to learn a lot about those thermodynamic packages. But basically, we can classify thermodynamic packages to two categories. There's some thermodynamic models that are valid for both vapor and liquid phase. These are the typical cubic equation of state models. If you have heard of the Peng-Robinson model, or the SRK model, or sometimes called RKS model, these are the typical cubic equation of state models. Van der Waals is another one, although it doesn't give the option for Van der Waals. Okay, so Van der Waals, Peng-Robinson, SRK, and you can see those choices here. If you scroll down, and they're alphabetical, you can see Peng-Robinson, you can see SRK, and these models are quite good if I don't have any polar components. So here I'm talking about single component. Is nitrogen a polar component? No. So cubic equation of state models are going to do the job fine. And they work for both vapor and liquid phase. However, if I have polar components, then the cubic equation state models do not work well. And then what you have to do is you have to use a different model for the vapor phase and a different model for the liquid phase. The models that you use in the liquid phase are activity coefficient models, and we're going to talk about activities and activity coefficients in this class. Okay? So notice that if I choose SRK, which is a cubic equation, that's all there is to it. If I choose Peng-Robinson, that's all there is to it. But if I choose NRTL, which is a non-random two liquids, it's an activity coefficient model, what do you see immediately? You see that this is for the liquid phase, and you see immediately vapor model. And I choose a different model for the vapor phase. The default is ideal gas, but you can see here that I could choose ideal gas, RK, virial equation, Peng-Robinson, SRK. These are good for vapor or liquid. Okay? The rule of thumb is very simple. Non-polar, cubic equation of state should work well. Polar, you use an activity coefficient model, and there are several. NRTL is the one I normally prefer to use, but there is Wilson, Margolis, many, yes.
What if you have a mixture of polar and non-polar?
Then you have to use the polar one. You need to be able to use the model for all your components.
Okay, so polar cubic or non-polar cubic?
Non-polar cubic. Any other questions? All right. So in our case, let's at the beginning choose, we have nothing polar, so let's choose the Peng-Robinson.
Didn't you add water?
Yes, but I'm not going to use water.
Okay.
But let's see, I'm doing it on purpose. Purpose I add water. I need to press X to exit, but